So we can see hands. How many people in high school or afterwards did sports or musical instrument, any sort of performance arts, debate, chess, any of these things? And when you train for these sports, right, or these activities, you practice, right? And usually you had some sort of coach or teacher, instructor, right? And they would tell you to practice, and you'd go and demonstrate in front of them, right? Um, and usually they would tell you practice like you can perform, right? So what do we do in computer science? Um, one of the skills you need are writing code, right? Programming, designing code. And what do we do? Well, let's see. How many people have taken a course where your assignments were graded by a program? No, but there's a program, right? And the program basically says, here's the input, give me that output, right? Doesn't matter what you do as long as the output's right. Another thing we do is, well, we hire graders to grade your assignments, right? And how well trained are they in grading assignments, looking at your code? Well, how many of you have been graders? And what do we do when you tell your graders, right? We say, look for this and this and this, right? Do you read their comments to see if they make sense? Or does the instructor say, make sure they've got comments? You know, so universities are not good at this, right? How important is practice? Is very important, right? And so the practice you're doing, right, writing code as during your school days carries over into your professional life. But we're not good at giving you feedback, right? So why do we write comments in code? Yeah, to help the next programmer understand what you're doing, right? This is my typical example. Do we need that comment? I mean, if the reader needs that comment, forget them, right? Because you'd have to write a book to explain what's going on if you don't understand that. Now, what's one thing we may need to comment about that line? Yeah, if the name doesn't, I mean, if the name doesn't tell the role, then we should change the name, right? What's not clear about this is why are we adding 1 to X, right? And why, yeah. So typically, if your code is clear, then what you're doing should be obvious. If you're doing something really tricky and convoluted, then you may want to say, how can I make it better, less convoluted, right? But of course, there are times when you're doing complicated things. I mean, you're taking a Fourier transform, that's just a complicated algorithm, and that's life, right? And so then you might want to comment what you're doing because it's so complicated. But most of the time, we're not doing complicated things like that, right? So what's really important here is why we're adding 1 to X, the why, not the what, right? And so you'll see a lot of does, right, next to your comments because, you know, if you're just repeating the code in English, unless the code is really complicated, you're just slowing the reader down, that's right? So I come across this line and say add 1 to x. Okay, yeah, but I knew that, right? You sort of force to read the comment, and it's like, oh yeah, but that's clear from the code, right? Why are you making me read it? And English is notoriously vague, right? It's not as precise as code, and so you start, and it's far more verbose than code is. So if you're just repeating the code, you probably don't need that comment unless it's really complicated. And then what you do is try and make it less complicated so you don't need the comment. So here's an example, right? Class to represent the priority queue. I mean, that's what the next line says, right? Fields. I mean, I once asked students, well, you know that someone might read it and not know what a constructor is. Then why are they reading your code, right? If someone doesn't know what a constructor is in Java, then what else don't they know about Java, right?
Should we assume whatever without being does?
Well, here we're not using any libraries, right? We're just talking about the basic syntax, right? Now the issue is, what do you do when you import some library and using it, right? Well, that's a slightly different story. But do you need to, how self-explanatory is that library? You know, if you're using a set, the name is pretty self-explanatory, right? Why do I have to explain what a set is, right? I mean,
The name isn't indicative at all what it's actually for. Like
yeah.
Library to manipulate databases and does the same. It's like psych.
Yeah, then it's like, but here, I mean, what's being commented is clearly obvious, right? Now, what's the difference between these two?
Right, is wasting space.
But that comment is what? It's a special syntax for JavaDoc, right? Right, so there's different, and Python has a similar structure, right? But it's inside the definition, and you get the triple quotes, right? And you use that to generate documentation from the class, right? Now that's slightly different because now you are generating sort of standard documentation that stands alone. And when you go to the Java API or even the Python API, right, eventually you see that documentation and they do things like comment what the size does, right? Just because for completeness. So if you're doing this to generate the documentation, it's probably okay. But I mean, you do have to realize that a function called size on a collection class has a pretty obvious meaning, right? And if it means anything else, you probably chose the wrong name, right?
We're saying that.
In general, yes. Some companies want you to produce Java docs, right? Some companies will say, here's what we expect you to do, and you comment every method with a boilerplate. Um, it's not something a lot of people recommend because then you write all this stuff which no one ever reads. But the first comment is just for internal to the code, right? The second one is designed to generate external documentation. So it takes more space. It's sort of irritating when you come across in the source code. I mean, if you ever read the source code for Java, I mean, it goes on for pages with all this stuff, and then you have to find, where's the code, right? But it's there to generate the documentation.
So, yes, this is actually a question. What level of like knowledge or skill should we assume the reader of our? Because something that I've always had trouble with is like obviously for somebody like you, I can assume they can read code, but in standard best practices, are you always assuming the audience is an engineer or somebody who's how to write code, or is this written in more of a thing or somewhere in between?
Well, again, we go back to why the comment's there. Help the reader out. Who's going to read your code? Mainly technical people, right? If non-technical people are going to read it, I mean, yeah, because I mean, if they don't understand the basic syntax of the language, it's going to be very hard, right? Um,
You might not want to write that in a month or 2 or 6 months later, you go, what would you look? Well, that makes a lot of sense. Because I know I've written code. I go back. This happened.
yeah, I mean, one of if managers did things properly, the best thing they could do is have you spend 6 months on maintenance. Because then you have to read all this code and then you realize, oh, wait, I can't understand it. Why? Um, the problem is managers aren't usually very good. And so if you go on maintenance, they don't ever take you off maintenance, right? So then everyone wants to avoid maintenance because you get stuck there. But the problem is you want that comment there to help someone to understand what's going on. And that doesn't help them, right? I mean, it's clear what this, if you're in a priority queue and you say size, it's pretty clear what that does. It doesn't help them. What's 150? Yeah, so it's 150, right? And you all know why it's 150, right? But in 6 months, do we know why it's 150? No, you're going to forget that, right? What's this 4.0, right? What's this 0.7, right? You know now because you just got done with the assignment. But in 6 months or a year, it's like, this is magic. Where does this number come from, right? Oh, so that's something that probably needs commenting because you need to help that person out, right? And of course, so what are these things? Oh, we can do things like, again, oh, if I do this, now it becomes clear what they're for, right?
You're saying that for this instance, obviously, part of the project, the correct way to handle this was not label value.
Well, so the issue is what needs to be commented in this assignment, right? Not the size, not what the fields are, but this is one example of things that and 6 months from now will be a mystery to everyone, right? And one way we can do it is this way, right? So what needs comment in this? Let's see, how many people like heap? What's the heap? Oh, I don't remember what heap is, right? We did this in 310 or sometime long ago. And then it was like, oh, you have to go up and down, right? Oh, then if I'm down the bottom, I have to figure out what my parent node is, and what's the indexing, oh. And then you finally realize, oh, wait, indexing becomes easier if we start indexing at 1, right? You probably didn't remember that right away. It wasn't like, oh, yeah, heap, starting it. You either figured it out after some time fiddling, or you read it, right? Later on, like you got in your book, or you went to Wikipedia and they say, I mean, here's the indexing, start at 1, right? There we go. It wasn't immediately obvious to you, and you had to look it up or think about it for a while. It's like, oh, what's going to happen in 6 months or a year from now? People look at your code and say, well, is that a mistake? Is this a bug that they're not using the first 0 index? Don't know, right? They might. And then what are they going to do? Oh, they're going to change your code to start at 0, and then they're going to realize indexing is a mess, right? Because it's really hard. So that's something that, right? If you have to look something up, or you need to sit down for 10 or 20 or 30 or an hour and a half or longer to figure something out, that's probably something that you're going to have to do again in 6 months or a year, right? So that's another thing you could have need to comment. Why did everyone skip this? I mean, leave that 0 location empty, or put a null thing in there, or right? We'll get to that.
On that note, what you said about having skipping the index, the comment you best put in like the initialize or like the constructor. Like why you made that design decision.
So the question is, where already put that comment, right? Where does the reader need to know about it? Well, the difficulty here is that there's going to be several places where they need to know it, right? Do you do it in every place, or do you do it in the top of the class and say, here's important, right?
Usually, top of the class, like you could say, oh, this is a priority queue. Here's what you kind of
Right.
describe it.
So here is, someone created a special class called element, and it contains 2 things, a student and a priority. And the role this plays is clear, right? Because when you add something to priority queue, you need 2 things, a thing you can put in the priority queue and its priority, right? And then they give it a student, and then the priority, this thing computes as priority. It doesn't normalize things, but that's another issue. Can we ever reuse this?
Device the way that you have a base class has subject priority and every class student.
But can we reuse this one? No. This only works in this assignment, right? We'll get to that. Yes. This one, right? I mean, what we're doing here is, this piece is reading just student data to compute the priority. So we talked last, about one of the reasons OOPS is good is because code reuse, right? But there's no code reuse here, right? We can never use this anywhere else, right? And so it only works in assignment. There's no code reuse. And we've hidden this computation, right? Because there's no way you're going to think of going to the element class to find out what the priority, how are we going to compute this priority, right? What about this? So I create a class, all else called association, and there's a key and a value. And they're generic types, so the key can be whatever I need to be, and the value could be a student, right? It's more generic. Where can we use this? Well, we can use it in a priority queue, right? Because I can put the key to be whatever I need to be, so it could be an int or an integer, whatever your language requires, and a student, right? And then we can put in, right? Where else can we use it? Well, if I've got a hash table or dictionary, it could be used there, right? Or in a priority queue or in a binary tree. This becomes usable in lots of places, right? And indeed, if you go in Java and you look at how their hash table is implemented, it's there, right? It doesn't use that name, but they hide it as an internal class. Why? Because, I mean, how are you going to implement a dictionary hash table? Well, you need the object itself, and you need, right, this hash, right? When you do a binary search tree, when you study it in the algorithms course, they just put numbers in, right? But I mean, why are we putting numbers in a binary search tree? I mean, that's stupid. It's just those are going to be the keys you're going to use, right? But then you want to associate, right, that key with some data. So all of a sudden, being slightly more generic, right, slightly more general, we get something that can be used multiple places.
Because a dictionary.
Well, there are different ways to implement those things, right? In some languages, they definitely do use this. But you see, okay, all of a sudden we get something slightly more general, slightly more useful. How many places are we going to have a priority queue that just holds students? What's that? Only in this assignment, right? And this one, I mean, how many times are we going to hold students in a priority queue? And the priority is going to be that. Only this assignment, right? Only this assignment. What about this? It's a generic priority, right? This can be reused.
So the correct approach we should have done is try to make it like that generic.
Well, we talked about why OOPS is good, right? And one of the reasons is we can flexibility and reuse, right? No reuse, right? This is just for this assignment, and you throw it away. Something like this, right, can be reused. Now I go back to the second slide where I talked about, do you participate these activities and practice, right? The problem is what I see is, yeah, you're busy, you're writing an assignment, and you're just like, do this, do this, do this. And you never step back and say, oh, wait, if I make it slightly more general, right, I can now get something that can be reused. And if you don't do that when you practice, when you jump to the real world, do you all of a sudden change your mindset? Probably not, right? Well, so the other question is, what do we do about the priority, right? And several people have asked that already. The question then becomes, can a student have different priorities? You know, what's the probability of it changing, right? If you do it this way, it's like, why is, right, the priority queue computing a priority for a student? Particularly when all the data comes from the student. It doesn't make any sense, right? If we put it in the student, then the student can only have one priority, and then like, we're sort of stuck, right? It's better than doing it this way, but still we're sort of limiting ourselves. Most of the people use Java. What does Java do in their priority queue? Anyone look? No. Nope. They don't do that. Check it how? No, because then you're assuming that your object always has only one priority, right? Right? Because as soon as I embed a priority method, whatever I call it, in my object, it's fixed, right?
How would you want to priority assignment? You'd have to put it into the priority queue class because the priority is how the data structure itself, necessarily the object put in it. But doesn't that then mean that you probably have to figure out a way to tell the priority queue how to calculate the priority based on like additional arguments?
Priority, check priority.
Once you embed it in the student class, you're fixed with one priority, right? If we embed it here, like here, then we're fixing a priority queue to a particular type of object, right? So one of the patterns we're going to talk about, not this week, but hopefully next week, we'll talk about how do we deal with this situation.
Formulas for calculating priority?
Yes, yes. And it has to be independent of the queue because we want the queue to be generic, to be reusable in different situations. So it can't be part of the queue and it can't be part of the student object because as soon as it is part of the student object, we're fixed, right? No.
This by like defining an inner class in the priority queue for each node, such that the inner node class contains that priority about the object that it's like a wrapper. So it still has all of the information about the node in addition to the priority as part of the priority queue rather than the student or whatever other type of object.
Like I said, we'll talk about this For the Python people, right, they went out of their way to restrict their priority queue, right, only hold students. Why?
Yes, we're thinking, to be fair, we had the class after the due date about, oh, we have to keep sending
How do Python collection classes handle dealing with this, right? They don't restrict the type, right? Now the Python does present a problem which, depending upon whether you're a strongly typed person or not, right, presents the issue of how do you prevent you adding a student object and then an alligator object and then an integer into the same priority queue, right? Whereas the Java people and the Swift people don't have that problem, right? When you instantiate your queue, you tell it what types of things can go in there. But as soon as you do that, I mean, now you've restricted it to, you've taken a general thing and made it very specific, right? Can only be used in this assignment.
So specific is basically the enemy, right?
Well, again, we talked about why is OO good. One reason is code reuse. Code reuse is not easy, right? If you don't think about it, it's not going to happen. Yeah, so did this. There's this one. I think this is a duplicate slide. Oh yes, naming convention, right? Right. Different languages have different naming conventions, and when you use a naming convention which isn't standard language, you stand out like a sore thumb. And people who are good at that language are going to look at you and say, yep, that's a novice. So you really want to understand the naming convention, right? Now what Pepe says is, look, here's a standard, but if you're in a company that already uses a different naming convention, then use theirs, right? But there was no prior code here, so
Correct. One should have said.
the underscore, right? Underscore, no capitals. Yeah, I mean, I don't like the underscore, but it sort of looks weird, right? And some of my age, we were trained early on never to use underscores because back then you printed out your code using a line printer, and the underscore character would run out of ink, and then you couldn't see it. And so a whole generation of programmers were trained never to use underscores because it wouldn't print out. Of course, that's long gone, but it still sticks in your head like, oh, to avoid this because of some old technology that died decades ago. Again, when we talk about classes, right, we ask what does a class represent? What abstraction is it, and what responsibility goes with that? And a priority queue, it shouldn't have to deal with computing a student's priority, right? So it's not the priority queue's responsibility to explicitly compute the student's priority.
I guess how, because since priority, I guess, is like the means by which the brain organizes itself, it seems like that would be kind of an inescapable feature of it.
But as soon as we do this explicitly, that priority queue can no longer be used anywhere else, right? So when it needs to know the priority, but as soon as you hard code the priority for a particular situation, right, we can no longer use it in Java's API because it only is good for that one situation.
You just need a separate function where you define priority.
We need something separate, yes. Right. So the question about using underscore, one, different languages have different conventions. You know, that's one convention that is used if you want to. It's particularly common in Python. It's not quite as common in Java. Some people use M. Yes, in Java, when you've got a constant, the convention is you capitalize everything and separate words with underscore. You know, so here putting the priority computation to student is better than putting it in a priority queue because it frees up the priority queue to be more generic, more general. But then there's only one priority. And what happens now if we want a priority queue to hold students based upon their GPA because at the end of the year we need to give out awards, right? And so we just want to do the GPA. Can't do it now, can we? Because that means we have to change that source code to have a different computation in the student class. And then we have to recompile that program, and then it won't work in this situation again, right?
So thinking about how to do this priority thing.
We will talk about this later. This is really complicated. It's hard to read. It's doing all this stuff, right? And then what you do is you pull out, pull out the print statement that's not useful, and you get rid of that check GPA variable, and you get this, right? And once you've done this, then you say, oh, wait a minute. I can just do this, right? What? Well, here, what I'm worried about is how it's done, right? So the whole assignment was basically, I didn't care what you did, right? So in general, when you computed the priority, you should have normalized it to make it make sense. But I didn't care because that was just a detail to see how you coded things, right? So here the issue is, yeah, it shouldn't be there, but that's really hard. You know, it's far more complicated than it needs to be, right? This does the same thing. It's simpler, it's shorter, and it's easier to understand what it's doing, right? And then of course, why is it doing this? But you come across this like, this is a big problem, right? This is a major problem. And so I do this, and I add a couple students, and then I create another queue. I don't put any students in it, and then I ask the size, and the size is 2. It's like, huh? Why is that?
It's share that same feature. So
Right,
you make another one. It's still
right. So this, I mean, making that array to be static means you can only have one priority queue in a program. And of course, they only wrote a one single program, right? And they only created one queue, and so it worked, right? But don't do this, right? It, um, this was even more subtle because the list itself was not static, but the size is static. And you go like, oh, that's going to cause some subtle bugs because you only got one size, and it's not going to be consistent with the actual number of elements in it, right? So you have to be careful. You don't use static unless you really need it, right? And you have to know what it means. It's only there, only one instance for all the objects of that type, right? Um, this is sort of pseudocode because the actual code is too long to fit in one slide, and why type it? So I come across a number of these where, okay, inside some class, there's some method. Here it is, ask for input, and then you write some prompt, enter a name, and then you read in the name, right? Then enter the GPA, and you enter a GPA, and it's like, why are you doing that, right? Because not only, it means that that code can only work when you're working on a command line, right? And it assumes someone's standing there at the command line reading it. Here's another version of this, right? So that in a student class, right, in a constructor, they have this code to, get all in. Here you pass it in, and if it's not valid, then you just print out a prompt, and then ask for, give me the real value. Again, you're assuming that someone's sitting there at the terminal watching this program run. When does that happen? Never, right? It's only when you're debugging. That's it. And so this does not work. What, in my mind, what's happening is there's a difference between writing a program and building classes, right? And when you're writing a program, it's like, oh, I do this and this and this, and okay, now I need this information, so I'll just ask for it. When you're writing a class, it's like, well, what are the responsibilities of the class? A class is not, a student should not be responsible for prompting the user, right? So one of the things I ask you to do is be able to print things out, right? And so I get this a lot. And well, the way I assigned points was the more I wanted you to pay attention, the more points I took off, right? It's like, okay, don't ever do this again. Um, Again, the problem with this is you can't use it, right? It goes to standard out. You can't use it in your code, right? You can't, that program It only works when you're in a command line, right? Can I use it in a GUI application? No. Can I use it in a server situation? No. Can I use it in the web? No. Can I use it in embedded software? No. When can I use it? When, what programs make use of standard in and standard out? What's that? Terminal things that are designed to run the command line, which how often does that happen? Well, Unix commands. If you write a Unix command, then yeah, you write standard out and read from standard in, right? This is, we can't use it, right? And you can't test it. How do you know it works? You think it works, but the problem with that is the more things like that you have, right? In 6 months, you're gonna have hundreds of them, and then you can't test them, right? Now, the Java people, how many classes in the Java JDK will print out things? Oh, but that's not printing out. That's an exception. It raises an exception, and then if you don't ever catch it, that goes to standard error, right? They never do it. Why? You can't test it, right? And you can't, I mean, here's all the places you can't use it, right? Which means it's basically nowhere, unless you're doing Unix commands, right? But how many people write Unix commands? Oh, if I do this, right? If I create a method, return it as a string, now I can use it in my program, right? And my print statement can be elsewhere, but not necessarily in the priority queue, right? I can test it, right? And I can use it in multiple places because my program cannot get the data. Of course, this solution is probably better because now I get the actual objects, right? And then I can, if I need to compute, I want them as a string, I can create the string. If I want to create a list, I can create a list, right? Whereas if I just get the string, now I have to sort of muck with the string and try and figure out some sort of format in the string that I can use to parse it. And it's like, what, you create the string and then you have to parse it in the same program? Why not just give you the objects, right? So the question is, what if I write the output to a file and then I check to see the file's increase in size? Well, does that mean it's the right output? It only means there's some output, right? Well, no, you just said the size of the file increased. You still don't know whether what's in the file is the right output. And then do you want your program to use this code or have to then read that file back in and then do something with it? It's not something I would recommend you doing. Oh, someone back.
I understand that you can't remove it, but the requirements you need to be able to print out.
Yes. Yes, and where does it go, right? Yeah, basically almost everyone did it, right? And that was a test, right? When we create classes, we ask, what should this class do, right? And so where does the responsibility go? And as soon as you put a print statement like system.out inside of a class, right, then that doesn't work. It doesn't work, right? And a number of people in various spots are printing things up, right? So it's not, and we get to it, we'll see some more examples.
How would you, in this case, return? So that returns the object generated.
Right.
How does that? I'm just confused. Would you also print it and return?
You need to return name and variety, not the whole object. So how do you put object return variety? Dot variety.
Okay, now you have to ask yourself, there's the general, right, and the specific, right? Once you start focusing too soon on specific, we restrict ourselves, right? When I do this is more general than printing it out, standard out, right? It's more useful. But now what we're doing is we're assuming what should be in that string, right? If I return this and I return the student objects, right, I can still then someplace get the name and the red ID and convert that to string and then print it out, right? Well, what? Yeah, what of what? No. What? In Swift and in Python and in Java, they all give you a way of iterating over a collection, right? This is a standard thing, right? And I'll say this is a more general solution than toString.
So like you overwrite the student, but also provide a generator.
Yeah, yeah, yeah. No, I mean, toString is a common method, right? And Java, that's pretty standard. Now, what I would do is I would do the iterator first, and then my toString would call it to get all the elements I want, and then convert to a string, right?
So you would keep your iterator in here, and then allow. You don't care name again class out.
Yeah, because, okay, in general, right, there are domain classes and there's interface classes, right? If we're dealing with GUIs and the GUI, right, if we're doing with command line, then it's system out. If you're doing with the back end, then you're just usually writing to a socket or to a file or to a database, right? No.
You want the iterator use log4j, that would be acceptable too, as long as it was have the name and nowhere else.
or somewhere else, not in the, right? Because as soon as we start doing it in a priority queue class, right, we're restricting, right? The purpose of this assignment was to, shake up a little bit, right? And to make you start thinking about, okay, what should we do with our classes, right? Because usually what happens is when you write this assignment, you're thinking about writing a program, right? And that's why there's a print statement there. That's why people are doing prompts inside their constructor, why they're, every time there's an error, some people, instead of doing an exception, they were like, invalid input, and printing the standard out. Well, you could see it, right? Oh, I've worked, right? But, that's not usable when you try and use that class in a real program. It doesn't work, right? What's that? Well, let's see. We can test it. Oh, I'll get to your question in a minute. Here's an example of like, oh, right. I mean, we can actually do things, right? I mean, do you want just a name? Do you want the red ID? Do you want everything? Do you want it, right? It becomes more generic, and it gives us more options as opposed to just, I mean, here it's like, oh, there's a problem, so I'm going to tell the user, right? But there is no user. It's, the priority queue is a collection class, right? Right, right. Let me, okay, what do we do here? What do you do when someone wants to remove something from a collection and it's empty? We can either return a value that is not success, or we can or raise an exception. Which one should we do? How do we decide? We have to make a decision, right? How do we decide? What's that? Well, here we're creating a collection class, right? What does Java do in this situation? Well, but you can't return true or false because you're expecting an object back, right? So the way I would decide is I would go to my class library and see what they do in similar situations. And the reason is that's what programmers expect to happen, right? Because when they use the built-in collection classes, that's the behavior. And then if it's a mission critical situation, they will then get the value and they'll check to see if it's null or not, if that's what Java does, and then raise exception there, right? But if you start doing, if all your classes do it differently than the Java classes, then you have to figure out, well, now I've got two different ways of handling the same situation. So it's much better to be consistent with the language in the library, right? Because otherwise you have to start figuring out, well, Joe wrote this code, so I have to handle it this way. And this is Java 1, so I have to do it this way. It's better to be consistent so we have fewer things to remember, and we can handle the cases all the same, right? And that's why I say, what do your classes do from that language? And you want to do the same because it makes things more uniform. It means there's less things you have to remember, right? Yeah, I mean, this is standard in, standard. It's only, I mean, that's it. That's what it's good for, right? It's not good for that. And it really, I mean, for like the first 10 years, there was no good way to read standard in. You had to do character by character. It was silly because they didn't think it was important, right? They really didn't think it was important because why would everyone do that? Here's another example of, I mean, like every class can have a main, right? Students do this a lot. I must admit that when I first started doing Java programming, right, it was like, oh, you write some code, you need to test, you run it, make sure it works, right? And so then how do you do it? Well, since Java didn't have a REPL, you had to write some code, right? And then you're like, okay, this is a pain in the ass to do. So what I wrote is I wrote a program which wrote this program and then run it, right? So look at your class, it'd find all the public methods, find all the names, find all the arguments, and then it would say, okay, which method, here's a list of methods, which one do you want to run? And then it would ask you for the input, right? And it's all automatic, right? And then when I came across Jane, I was like, oh, my way is just stupid. This is the way to do it. And so I deleted all that code because even though this is being generated automatically, it's still slightly painful to use, right? Some students did a lot of work to do this, right? And then you can enter things, and they had all this printout, and I was like, it doesn't work in the real world, right? How many classes do you think you're going to produce as a team over a year? And are you then going to run all those mains? No. For one thing, after 6 months, you're going to forget what the right output is, right? JUnit has its problems, right? But it has far fewer problems than doing this. Right. What is that method called in your language? What? What language you're talking about? In Java, what's it called? You're guessing, right? You don't know. Did you look at the priority queue class? Why? Pull? No, it's not pull. Right? And why does it matter what they do in Java? If you're a Java programmer or if you're a Python programmer, what does it matter what they do in Python?
Because conventions aren't just restricted to variables and functions. There's more to a convention.
Yes, it's a convention, and if you follow the convention, it becomes easier for everyone to know what's going on, right? If you don't follow the convention, then you have to remember what other people did, right? And more importantly, we talked about, one of the important things about object-oriented programming is flexibility, right? If you use different names, there's no way you can substitute your class for one of their classes because all the function names are different, right? But if you follow their conventions and use the same names, right, and you want to replace your priority queue with their priority queue, it works, right? What's that?
A specific student. It's just
Yeah, but remove student, what does it do?